All right, so we're gonna go talk about. All right, be quiet. So yeah, you don't have homework yesterday, which is good. Hopefully you get some good sleep. Oh, make sure register for AP Classroom. So if you can do that now, get a computer out and register for AP Classroom. I've sent a code on group chat. And I think I'm the last teacher to register for that. They sent me emails like, yeah, Mr. Ye, you're the last one. You can do it. No problem. Now, make sure you use the code for 6th period. I don't know, what is it? Somebody write it on the board. Yeah, if you can. Make sure you write on 6th period one. Otherwise, it's everybody drawing their own class. That's a funny way to write a 4.
Really?
Write it again.
I think it's a normal way to write a 4.
No, that's not how she wrote it the other way.
How did you write it?
Yeah, she wrote it that way.
Wait, how did you write it?
I don't write
Weird. Well, like, that's a mystery. Wait, I've heard a different way like that. And I'm lovely with this.
They're not the same.
How do you write it?
I write it this way. Like what most people do. All right, get your notes out. Hopefully you register that very quickly. All right. All right, so what we're gonna do is we're gonna talk about continuous versus differentiable first before we talk about power rule. So continuous versus differentiable. Differentiable. So this is probably the most important diagram of the whole AP calculus because this is a diagram I kind of invented myself. And it's a very help. I mean, I train other teachers to do the same thing, so that's one thing I'm kind of proud of.
Is it the food pyramid?
No. 3.
It's food.
Okay, so they are 3 tier. Now, of course, you cannot have a bottom. You cannot have a top tier without a bottom here, so you have to understand what's the base building block of this. The first building block is limits exist. And the way to write in math is going to be limits as x approached a from the left of f of x is equal to limits x approached a from the right of f of x. And in terms of this, in terms of graphing, will probably look like something like this. Now, am I missing Jesus?
Yeah. What?
No, now, if Aspen, you need to move your seat a little bit so you can see, so you don't have to turn all the way around. You can, as well as Misha as well, because those are two most awkward seats in terms of taking notes.
Just pull me through your screen. Just pull me through your screen.
All right. So you can move your chair a little bit this way too. There we go. All right. The second tier. The second tier is continuous. The continuous, we know there was 3 conditions. What is the first condition as on your test? I'm surprised, like, people got this one wrong. Like, yes, Benicia?
F of A must be defined.
F of A must be defined. So if we define, what does that look like? It's a closed circle in a graph. Okay, so that's the first condition. What will be the second condition? Yes, Amen.
Limit x approach to a has to exist.
Limit x approach to a must exist. And so what does exist look like, first of all? The holes with the line to connect it, right? But does that have to equal to the black hole? Right now it doesn't, because before right now I'm just like this. But right now it's not also not continuous either. So the third reason is going to be, well, when limits as x approach to a of f of x is equal to f of a. So that's the only reason that this will be connected. So I'm going to move this like up here. And so, okay, well, that is continuous. Now, imagine that you're riding a roller coaster, right? So roller coaster in terms of here is kind of like a broken roller coaster. Now, this is just analogy, so help you understand. But don't write that on AP exam because they don't understand you. So this is a broken roller coaster in terms of limit exists, because imagine that you're a roller coaster like this and there's a hole there, right? So you don't want to be like that. Okay, and then this one is a connected roller coaster, but connected roller coaster. So it's not really very good roller coaster to ride on. It's not going to be pleasant because you can fly out of track and you're still going to die. The last one is differentiable. Well, what does differentiable look like? Okay, differentiable. So differentiable is slope from left equal to slope from right. And that's the way to think about it. Or I call that a functional roller coaster, like functional roller coaster. So what is that in terms of math? What does math look like? Well, math is just look like this. Limits as x approach a from the left. Now instead of f of x, in this case is f prime of x because we compare the slope, equal to limit x approach to a from the right of f prime of x. So slope on the left equal to slope on the right. In terms of roller coaster, it's going to be like this, right? It's very smooth, right? The slope of here on the front wheel and the back wheel is roughly the same. It's only like a minuscule changes, and each change is very, very small. So it's completely smooth if you ride on that roller coaster, right? This one is like, I don't know. This one's like Phileas and Ferb, like roller coaster, right? Phileas and Ferb can probably do this. One of the best cartoons I ever make. You agree?
Yeah, I guess.
It's just so imaginative. It's like so interesting. I love it. I don't know. I watch the same episode like 100 times. That, however, I always wanted the Candace win once, just once.
Yeah.
There was an episode of that.
Yeah, but that's a movie. It wasn't. It was just a
No,
movie.
she wins in her like dream or whatever.
Yeah, but dream doesn't. It's
And
not
then
real.
And then the timeline changes and it's like all horrible.
Yeah. Like you're just looking for that. Like every day, you're actually rooting for Candace. All right. So let's get back to the track. Sorry, I got off track. So when function is not differentiable, when function not differentiable at, well, first time is when a function is not continuous. There are a couple situations where not continuous. You could have a whole, or B a vertical asymptote. So this is the first situation, it's not differentiable. Second situation is also is a not very mathematical to say this, but it's a sharp turn. Sharp turn. So don't write that on an AP exam. So it's sharp turn. So the sharp turn could be like a situation A is gonna be f of x. Can you think of a function that has sharp turn?
Absolute value.
Absolute value x. Good. So that's a sharp turn. So this got a absolute value function that it has a term of slope from -1 to +1. So this m is equal to -1, m equal to +1. This is not differentiable here. Not differentiable. So it's not differentiable. The third situation is kind of weird because third situation doesn't really work with roller coaster, but it's not differentiable as well. But this one is kind of hard to remember. It's called vertical tangent. Vertical tangent. When you have something that's vertical tangent, it's not differentiable. Now, what does a vertical tangent look like? Okay. So there are some situations where they are both. So 2 and 3 can be both. That's going to be a cusp. Cusp is going to be x to the even over odd power. So 2 over third is perfect one. So it's even over odd power. So a cusp is a very good representation of both sharp turn and vertical tangent at the same time. And I think about 2/3 is actually interesting. If you have x to the 2/3, it should look like x. And usually work with the odd over even. No, sorry, even over odd. It looks like this, right? Now, if you look at here, the slope at 0 is actually a straight line, a straight vertical line if you zoom in enough. So it's going to be a vertical line from both sides. So the slope is actually vertical tangent as well. Now this is one example of vertical tangent and sharp turn at the same time. And this is not how you want to ride a roller coaster. Yeah, it's not very nice. Maybe after my test. Yeah, maybe after my test. Don't do self-harm, guys. I'm not Mr. Graham. Anybody have Mr. Graham? He likes to make self-harm jokes, right?
What joke?
Self-harm. He hasn't yet.
Oh, self-harm.
Yes. How do you tell something's a vertical tangent? It's kind of hard to see, but I'm gonna give an example instead, so that way it's easier to see. I love Mr. Graham though. So x to the 1/3, this has a vertical tangent, and I'll show you what an x to the 1/3 graph look like. X to 1/3 look at, well, we already saw one. The cusp is a vertical tangent as well. But this one's actually this. This one's graph's gonna be like this. So do you see this point has a vertical slope? So that's called a vertical tangent. Okay, so if you have vertical tangent, it's automatically not differentiable. Now I'm going to prove it use the definition of alternative derivative. So what is the definition of alternative derivative again? Which is you're going to have on tomorrow's test, alternative and definition of derivative. So x approach to c, right? F of x minus f of c over x minus c. And this is prime. So let's just take a derivative of f prime of 0 in this case. It'll be limit x approach 0 of f of x. What's the f of x here? X to the 1/3 minus, well, f of 0 is going to be 0. Is that okay? Over x minus 0 again. So you say, oh, okay, well, that's limits as x approach 0, x to the 1/3 over x. That can be simplified down to limits x approach 0, x to the 1/3 minus 1. Also is limits x approach 0 of x to the negative 2/3, which is limits x approach 0 of 1 over x to the 2/3. Now, what happened when x approach 0? What would the slope be? Slowly, if I approach 0 from the positive side, because we know it's either infinity or negative infinity. Because if this is 1 over 0 situation, so what will it be here? If we approach 0, it's going to be what? It's infinity. Good. In terms of this, it's going to be an infinity slope. Infinity slope, I mean, slope is so deep that you can stand on that top of this line, right? So those are the things that you have to pay attention. Can I open the door for Wei?
Why is this not infinity?
Because imagine that slope is 2, right? 3, 4, 5, 6, 7, 8, 9, 10. And if it's in straight line, it's infinity. Like, it's just going, there's no next step. There's like a wall. Like, wall is like a infinite slope. It's like,
Yeah, but I thought you plugged in 0.
if I plug in 0, it can be two things because that's the number over 0, right? Number over 0 can be infinity or negative infinity. So you plug in 0.1. If I plug in 0.1, it's going to be positive infinity. If I plug in negative 0.1, it's still going to be positive infinity because it's 2 power 2 there. So that's going to be a vertical tangent still.
Did you say that exam tomorrow?
Not test, quiz. Just 2 questions. You got to use definition of derivative and definition of alternative derivative. Okay. Yes, Alvin?
I'm still just having a hard time visualizing how it's infinity. Like, I get that it's going straight up, but how do you know it's going straight up?
1 over small value.
If you plug in 0, both, huh?
it would say.
Yeah, it's like 1/0.9.
1.1 over 0.00001. The value is going to be so big, the more smaller I get, the bigger the value is going to be. So they all go into infinity. And also 2/3 power is 2 power at the end, so you're going to square. If you square at the end, it's always going to be positive. So in this case, it's positive infinity. Yes.
0.1.
Huh?
You plug in the 0.1.
Yep.
Then regular 0.
I don't know what that value is, but it's going to get smaller. You're going to get smaller and smaller. You're not just only plug in 0.1. You plug in 0.00000000000. Keep on going. What? Okay, so let's look at another case. Is x minus 2. And this one is on it's interesting because this one is going to look like this. At 2 is going to be a x minus 2 function. At this, it's going to be negative x minus 2. Is that okay? We talk about one side is a negative function, one side is a right function. Now, what happens if you have limit x approach 2 in this case? Well, I'm going to do it from both sides. X approach 2 from the left. So f prime of negative 2. Hopefully, we can do derivative of this. But if we cannot, that's okay. So we just f prime of negative 2. So I'm going to try to take a derivative. I don't know if it works, but I'm going to try. So I'm going to say f prime of for 2, so for positive 2. So of course I'm going to use definition of derivative. F of x is going to be x minus 2, but from the left side it'll be negative x minus 2. Is that okay? Minus f of 2 is what? What's the f of 2? Plug in 2 here. 2 minus 2 is what? And then on the bottom is x minus 2. Well, it turns out those two can cancel. That's equal to negative 1. So slope from the left is m is equal to negative 1. Does that make sense? You can by looking at it too. What? 2 x minus c. Now I'm going to plug in from the right side, right? I'm going to do the same thing, approach 2 to the right side. So that is going to be x minus 2 over x minus 2 because I'm using the right side function. And that's going to be 1 rather than negative 1. So f prime of 2 does not exist. Why? Because left side slope does not equal to right side slope. Therefore, they're not congruent. Therefore, that is going to be, does not exist, so f prime of 2. I take a derivative from both ends. I figure out they both equal to different value. And that's the things that we figure out. There we go. Differentiable, continuous, very little things that you guys can understand. So this is hopefully this is very, very important. Jesus, you need to show up to class. Shout out to Jesus. Try to address him as chat. I heard Ben is a streamer. Somebody told me you're a streamer. Yeah, you're not a streamer?
I do.
What do you stream? What kind of game? Minecraft? That's pretty cool. Do you make a lot of money?
No, I think I paid like maybe.
Do they send you a check for $5?
Somebody sent me $5.
Oh, $5 donation. Oh, that's cool.
Wait. It's like say thank you for 5 minutes. I think I can like give subscriptions to other people watching. Yeah. Okay, and it gives unlike the other people that get service randomly or I have that.
Oh.
My total revenue would be like
That's pretty sad.
they don't pay you.
Oh, okay. All right, so imagine if I take a derivative of a constant. So d to the dx is take a derivative of of something. You take a derivative with respect to x on a c. What do you think derivative of c is? Benicia?
0.
Why do you think 0 is a horizontal line? Did we talk about this? Okay, so y equal to 2 is a horizontal line, which is the c is a constant. Doesn't matter what c value is. C could be 2, could be 3, could be 4. So I here y equal to 2. Now what is the slope? Slope is going to be 0, so that's going to be 0 here. So derivative of d to the dx of c is equal to 0. Is that okay?
What equals 0 there? That's right in the slope.
The slope.
That's
M is the slope. Yeah, Kaden?
What's this d?
D is taking derivative with respect to x. D over dx.
Okay.
I'm taking derivative with respect to x. We're going to talk about that as implicit derivative. Okay, so imagine you take a derivative of something. You're looking for the slope of something. Now, if a y equal to 2, or y equal to 3, or y equal to 4, that's a function, which is a constant. If you look at those lines, what is the slope of those lines? Well, it's a horizontal line. The slope must be equal to 0 because there's
How do you know that that's a horizontal line or like line?
y equal to 2. Y equal to 2. When you graph y equal to 2 on decimal, it's going to be a horizontal line.
D over dx.
D over dx is taking derivative with respect to x. So you're taking derivative. You're finding the slope of a horizontal line. C is a horizontal. Baden, you don't understand what C is a horizontal line? If I ever grab, I can only talk one. If you have any question, just ask. Let's say y equal to 2, it's going to be a horizontal line. If y equal to any number, it doesn't matter what C value is, it's always horizontal line. The slope is always 0 because there is no rise over run. Okay, so what about d to the dx of x to the n? Now, a lot of you guys wish me I teach you this a long time ago. But I know some of you guys are weak in algebra, so I need that you know how to do definition and derivative, you know how to do conjugate, how to combine fraction, and how all this stuff. But now we can teach you a shortcut. There's a shortcut, it's called power rule. So a power rule is gonna be make sure that you drop the n that go into the front and then n minus 1. So there's gonna be n x to the n minus 1. Make sure power subtract 1, the power becomes the coefficient. That's pretty much it. Imagine that if you were to take a derivative of x and you say, I want to take a derivative of x squared. What's the derivative of x squared? Well, 2 is going to be in the front, right? So 2 is in the front, but the power is going to subtract 1, so it'll be 2x. Super easy. However, I'm going to tell you one more thing, something to pay attention to. Make sure owning x to the n is on numerator. If it's on denominator, it doesn't work. If 1 over x squared does not work, you have to convert it to the other way. X to the whatever power it is.
But does it apply to like only derivatives or just all x?
Only derivative of a function.
Do it if it was a negative exponent.
Oh yeah, of course. You can do it with a negative exponent. We're going to talk about that. So imagine this. What's the derivative of also we're going to talk about derivative of a constant and f of x. So if you ever have a constant, you can take it outside here. Right? So d to the dx of c of f of x. So that can be true. And that'll be c. Now derivative of f of x is going to be f prime of x. It can be like that. So if I have d to the dx of 4x squared, then 4 is going to be in the front. And then 4 times 2 times x to the 2 minus 1. That's equal to ax. So that's the derivative of this. Derivative of 4x squared is equal to ax. Super easy. So I'm going to ask you a couple of things. What happens if I have derivative of 5x? There's two ways to look at this. What's derivative of 5x? Which is what? What's derivative of 5x? Alan?
25.
What? 25? No, that's way too big. Neil, what do you think? Derivative of 5x. No? Okay, Panisha?
Isn't it just one?
No. Gabby? It's a 5. Look, there's two ways to look at it. Two ways to look at it. Imagine y equal to 5x. What is slope if y equal to 5x? If y equal to 5x, the slope is going to be the number in front of x, right? So derivative of 5x is 5. Or you want to do a power rule, which is kind of redundant. If you do that, you can take out a 5. This is x to the 1. 1 drop in the front, so it'll be 5 times 1 times x to the 1 minus 1. So it'll be 5 times x to the 0 power. X to the 0 power is 1, so the answer is 5. But this is way too long to do something. You take a derivative of 5x, just 5. You look at y equal to mx plus b. Does that make sense? Yes. You can do that if you want. It just lets you to see what happened. What actually happened. Because a lot of people don't pay attention to this detail. This is the first year I'm actually going through this details. Because I usually don't go this slow. But I need to make sure everybody on par. So how do I take a derivative of this though? Three over x squared. Do you guys see the problem here? This question. No. So in algebra, hopefully you guys know your algebra rule. A to the negative n equal to 1 over a to the n, or 1 over a to the negative n equal to n to the 1, like this. We are actually going this way because that's equal to d to the dx 3, and I cannot take a derivative of x is on the bottom. X need to move to the top. So therefore it's going to be x to the negative 2. Is that okay? Using negative exponent rule. And if you do that, 3 times negative 2 times x to the negative 3, it's negative 6 over x cubed. This is your final answer. Hopefully you get this. Yeah, no, I hear the wrong if you say the right. I'm sorry. So negative 6 over x cubed. Is that okay? That's fairly easy, right? How about d to the dx of, I don't know, 3x root x. No, I mean, let's just change this to 4. I don't like 3 now. I'm going to do 4. So how do I take a derivative of 4 over x root x? Knowing your algebra is going to be so helpful. The problem is people cannot do calculus is because they don't do algebra. If you give me a good algebra 1 student at 6th grade, I can teach you calculus at 6th grade. I've done it before. Well, radical is it could be a rational exponent. So the you can like x times root x. Well, using the exponent rule, 4x to the x to the 1/2. Would you agree? And that's d to the dx of 4 over x to the 3 over 2. 4x to the negative 3 over 2. Does that make sense? I haven't taken derivative yet. That's why the derivative notation is still in the front. I only do algebra, and the algebra kind of helped me here. Now I'm going to take a derivative. Or you can say negative 6x to the 5 over 2. Now, this is an acceptable answer. I like this answer because it's easy to plug in. Or you can be like this. That's also acceptable. But I actually prefer this because I like a rational exponent rather than radical. But sometimes your answer could be radical as well. So you have to pick out the right one. But you got to know how to simplify radicals. So I'm going to give you a 5 for you to take practice. But make sure algebra comes first, okay? So the first question is I want you to take a derivative. It's 5 over 2x to the third. The second one I want you to do is 5 over 2x to the third. They look really much the same. Y equal to 7 over 3x to the negative 2. Lastly, y equal to 7 over 3x to the negative 2. So I want to take a derivative of all this function. But I will rewrite all the function before I take a derivative. That's just me. But also the thing that kills you is algebra again is not calculus. Most of the students struggle is because calculus is not calculus. Understand calculus, a third grader can understand. But the algebra is really hard because you don't have a really good structure when you come out of algebra class. The youngest student I ever teach calculus is 4th grade. Huh? What did you say? I don't think you wish me for grade teacher.
Is the denominator for 2x 3?
3, yeah, it's 3. On the last two?
Yeah.
7.
You multiply 3 on the what about the 2x? I moved because the 2 and the x are together, so I just moved the x. I made the 2 and the cross. You can't multiply the 5 with 2 because 2 is the negative. I looked into
This is what, Thornbrook? I didn't know you got a Holy Family. You look like a Thornbrook kid. Okay. You are Thornbrook? Okay, so first thing I rewrite this. Do you see what I do? I rewrite to the numerator so I can take a derivative. Did you do that? Now I'm gonna say y prime. This was 5 over 2. X to that's gonna be negative 3 down. X to the negative 4. So it'll be negative 15 over 2. X to the negative 4 is equal to negative 15 over 2. X to the 4 on the bottom. And that should be the first one. Because that's the exponent rules. Make sure your exponent rules work.
Oh yeah.
Now, what's the difference between the first thing and the second thing?
2 is cubed.
Yep, 2 is cubed. So you gotta be careful. When you have a parenthesis, that 3 is going to apply to both. So you're going to do the same thing, 5 over 8 x to the negative 3. Now I'm going to take a derivative. So now you see I write differently. Y prime is equal to 5 over 8 times the negative 3 times x to the negative 4, which is negative 15 over 8x to the 4th. And this is my final answer. How about the next one? Can I rewrite this? Somebody open the door for Misha. Oh, not Misha, but somebody. Somebody. Oh. You guys both have firm hair, so I cannot tell. Misha has a hair naturally curly.
Yeah. It'd be weird if I curl it.
Can you comb it straight? Can you make it straight?
Or get this way.
But you can straighten it, right? Have you ever done it before?
I literally came for something.
Okay, so x to the 2 is on the top, right? So y prime is going to be 14 over 3x. Is that okay? Is that okay? Now the problem with this one is they both are negative 2. So then I can rewrite this is equal to 7 times 9 times x to the 2. So if I take a derivative of this, y prime is equal to 126x. 3 to the negative 2?
Yeah.
Is equal to, this is 1, that's equal to 3 squared. Because you switch to the top, make it positive. That's how you do exponent rule.
Oh.
Those are exponent rule I write down right somewhere. I don't know what I write down for.
Yeah, isn't it 63?
Yeah, it is 63x squared, but I haven't taken derivative yet. Why are you so slow, Nelly? You make fun of a teacher to teach you 1 plus 1. Now we cannot do 63 times 2? It's 36. All right, so can I take a derivative of 2 terms? Of course I can. I can take a derivative of multiple terms. What's the derivative of this?
Oh, we love it.
What's the derivative of 3x squared, Alan? No, you're a dumbass. It's okay, I love you, Alan. Six x plus 6, thank you. It's on live stream now. Mystery and call a student a dumbass. Click that, put it on TikTok short.
I'm thinking about making a Mr. Yay edit, and then waiting for you to say like hard quotes so I can put it in the edit.
No.
I'm like, what? Where? I'm like, you gotta take this kind
That'll be actually pretty funny. Okay, 6x plus 6, because derivative of 6 is 0. Derivative of 6x, the slope of 6x is 6. And you can take a derivative individually. Can you take a derivative of something like this? How would I take a derivative of something like that? Think algebra before you think calculus. So if I expand this, of course I can expand this, and expand this is not 4x squared plus 9. It's actually, I know some of you guys are thinking that, please don't do that. That's equal to 4x squared plus 12x plus 9. And if I take a derivative of this, it's going to be 8x plus 12. And that's done.
I thought it was a cute where.
Okay, so I hear nothing. Okay, so I always choose to do algebra in this case, just because I think like there was a rule later called quotient rule, but if you use quotient rule for this question, it's actually worse. So make sure when bottom's one term, make sure you do algebra first. So you see this bottom's one term. So this is the one term. It's always think about splitting. Split. And that's why I do the question on my review sheet on algebra. But I'm going to expand the top first. So if I expand the top, it's going to be x minus 6 root x plus 9 over root x. Now what I would do is, I won't even take a derivative yet. I would just do x over root x minus 6 root x over root x plus 9 over root x. Now I can simplify this. This one's x to 1/2. Is that okay? 1 minus 1/2 is equal to 1/2. This cross it out. And that's going to be 0, right? This is 6, but derivative of that. Oh, no, sorry. This one's going to be minus 6. And this is plus 9x to the negative 1/2. I haven't taken a derivative yet. Only I do is algebra step. And I didn't do derivative yet. So now I'm going to do derivative. So it'll be 1/2 x to the negative 1/2. What's derivative of 6? And this one negative 3/2. So it'll be 1 over 2 root x minus 9 over 2 x to the 3 over 2. So you can do that. That's fine. Or 1 over 2 root x minus 9 over 2 x root x. Either one's acceptable, so I will probably do this. And that's just a derivative.
I can figure it out.
Yeah.
It makes sense. And what's it about? Stuff you're doing
What?
Is next week have anything to do with this stuff?
Next week's problem. I don't plan that far. I might die over the weekend. So if I plan that far, I waste a plan. Sorry, kind of dark.